Good day, students. Welcome again to physics class. And today we'll be treating measurement of heat energy. Now, heat energy is the energy that is being transferred from a hot object to a cooler object as a result of their temperature difference. In terms of energy and transfer of heat always tends to flow from a hotter object to a cooler object, and never does the reverse occur. Now, such energy always flow from the hot object to the cold object. Heat energy is only one form of energy and is called thermal energy. Like other forms of energy, it is measured in joules. Now, this chapter will introduce or discuss two important concepts of heat energy, that is specific heat and latent heat or thermal heat. Now, we shall also treat other related topics such as evaporation, boiling, and sublimation. And at the end of this chapter, we should be able to 1. Explain the relationship between the heat supplied to a substance and its temperature change at constant mass, and also its mass at constant temperature change. We should be able to also explain the terms specific heat capacity and thermal capacity. 3. We should be able to also explain why there is unequal rise in temperature for different substances of the same mass supplied with the same quantity of heat. As we go forward, we also see what we are expected to know at the end of this chapter. So we'll proceed. Now, continuing on what we are expected to know at the end of this topic. First, we are expected to know and state the assumptions underlying the experiments involving the measurement of heat quantities. 5th, calculate unknown quantities using the relation that quantity of heat H is equal to mc theta, change in temperature, when no change of state is involved. 6th, determine the melting point of a solid. We are able to also determine the boiling point of a given liquid. List the effect of impurities and pressure on the melting point of solid, taking ice as a case study, and also the boiling point of a liquid. Solve simple problems involving latent heat. We should be able to also distinguish between evaporation and boiling and explain sublimation. Explain the working principle of such common devices as a refrigerator, air conditioner, and pressure cooker. Explain the effect of humidity on personal comfort. Now we'll move into specific heat. Experiments show that the rise in temperature of a body is proportional to the quantity of heat supplied to the body, the mass of the body, and the nature of the substance of the body. Now, we can in general write that we will see the equation that supports this. And from experiment, as we say, we'll see that the rise in temperature of a body is proportional to the quantity of heat that is being supplied. The rise in temperature, in other words, more increase in heat brings about temperature change. And when we reduce the heat, it's expected that the temperature will also reduce. As we go on now, we'll see the equation that connects this experiment and theory. We'll continue. Now, as we said before, that the experiments have shown that the rise in temperature of a body is dependent on the amount of heat that is being supplied to that body, the mass of the body, and the nature of the body. Now, in general, we'll state that H is equals to mc theta, where H here now is the quantity of heat, M is the mass of the body, Y theta is the change in heat temperature, and C is a constant known as the specific heat capacity of the body. This constant is dependent on the nature of the body. And from equation H, as we have here, we can write that C, that is making C, that is the specific heat capacity, the subject of the formula, to be equals to H over m theta. Hence, we can define C, that is the specific heat capacity. The specific heat capacity C of a substance is the quantity of heat required to raise the temperature of a unit mass of the substance by 1 degree Celsius or 1 Kelvin. When H is in joules, M in kilogram, and theta in degrees Celsius or Kelvin, then the unit of specific heat capacity is joules per kilogram per Kelvin. that is joules per kilogram per Kelvin. Now, water has a specific heat capacity of 4,200 joules per kilogram per Kelvin, or 42 joule gram Kelvin. Thus, to raise the temperature of 1 kilogram of water by 1 Kelvin, we require 4,200 joules of heat. Now, here are some substances with their specific heat capacity. Here we have aluminium. Aluminium has a specific heat capacity of 900. We have brass to be 380, copper 390, glass 670, iron 129. Iron 460, lead 129, and platinum 135. We'll continue.
Admission. JU Consult is admitting students to its e-learning program for secondary school dropouts from SS1 to SS3 for both traders, ogas and madams, business owners, politicians, and others who need secondary school qualifications. Register with us today as you study with your phone, laptop, DVD player, anywhere, anytime, without disturbing your work. Join us or sponsor someone today. The person will ever be grateful to you. For further information, visit www.jeyouconsult.com. You can also call or WhatsApp 0810-836-9791 or 0905-093-0561. Tell a friend to tell a friend.